Now finally, we're going to discuss about the fundamental theorem of algebra. Now we've been doing things that are similar to this for the last couple classes, right? Like factoring and like we're kind of just using the fundamental theorem of algebra, even if they're not realizing it. Like, factoring like, I don't know, x times x, I think it was plus 5 times x minus 4. Like, it not might look like it because like we're factoring, but this is the fundamental theorem of algebra, right? It states that any polynomial can be factored as the leading term times some number of linear factors. So I'm just going to spend one problem on this because we've been already doing polynomials for 2 weeks, and I don't exactly want to bore you out. So I'm going to finish this week out with polynomials, and then I'm going to, move on to something else. So, this problem states that a polynomial function f of x of least degree has zeros 1, 1, and 2. If f of 4 is equal to 1, find f of x. Now we can use the fundamental theorem of algebra by seeing that because it has zeros 1, 1, and 2, it can be written as first x minus 1 times x minus 1 times x minus 2. Now these zeros don't have to be distinct. So what that means is that you can have 10 zeros that are all 1. So these, 10 zeros are called multiplicity 10. Or in other words, this would have multiplicity. I'm not sure if I'm spelling this correctly, but multiplicity of 2. So multiplicity 2 means that there's 2 1s, and here there's also 1, 2. So we have 1, we have the 0, 1 of multiplicity 2. Now here's where that least degree comes in. So what we can do actually is, we can add another 0. It doesn't say that we can't add 5 of a 0, right? We can say that our polynomial function is like this, right? But it says least degree, and if we add another linear term, then we're going to have x times x times x times x. So we're going to have an x to the 4th term. Why do we have that? It's of least degree. So if we get rid of that, useless x minus 5 term, then we just have x times x times x, which we get x cubed. So the largest power here is x cubed. So that just means that degree is getting smaller. So that tells us that our function only has these 3 zeros if we want to answer the problem correctly. And also it states that the fundamental theorem of algebra also has a leading term a. So in the polynomial function of a n times x to the n, we do have that a, that leading term in the polynomial, in the factored form of the polynomial function. So this is equal to f of x. And now we'll use that last bit of information. F of 4 is equal to 1. So that means if we replace all of the x's with 4's, we should get 1. So that means a times 4 minus 1 times 4 minus 1 times 4 minus 2 is equal to f of 4 is equal to 1. So this, the whole thing over here is just 3 times 3 times 2 times a equals 1. 18a equals 1, and a is 1/18. So our answer, f of x, is just replacing the a with 1/18. We have 1/18, and a little bit of simplification here. We have 1/18 times x minus 1 squared times x minus 2. Now, if you want to actually, fill out all of those, polynomial functions by, multiplying all this stuff out, doing that, you can do that. But because it just said find f of x, it doesn't say that you have to put it in the general form, a n times x to the n and on. So we are just fine with the simplicity as it is right now. 1/18 times x minus 1 squared times x minus 2.